Number 48. It says a certain manufacturer makes 400-watt light bulbs. Assume that these light bulbs have lifetimes that are normally distributed. When you see normally distributed, as we see right here, that represents us. That means we can use the normal distribution curve, which means we can standardize our scores and then go to the z-score table or the standard normal distribution table to find the probability, to find the area under the curve, or to even find a percentage. Anyways, with a mean lifetime of 680 hours and a standard deviation of 125 hours, use a standard normal table or calculator to find a percentage of light bulbs with lifetimes shorter than 720 hours. For your intermediate computations, use 4 or more decimal places. Give your final answer 2 decimal places. For example, 98.23%. I don't know why I read the example. Now, in Stats 250, you will see different symbols for the mean and the standard deviation. But this chapter in this textbook on ALEKS, it likes to focus on samples. When you go to Stats 250, instead of you seeing the sample mean, you're going to see something called mu. And mu means population mean. And we'll say that mu equals to 680 hours. That's for Stats 250. I want you guys to, to be able to make a connection. You'll be seeing lowercase sigma for standard deviation, which is your population standard deviation. I'm going to abbreviate standard deviation, STDEV, and that'll be 125. Some of your professors may even use it like that, but I want to keep it consistent in terms of ALEKS in the text. So I'm going to draw my bell-shaped curve. Put my mean in the middle. My mean is 680. 1, 2, 3. Putting your standard deviations are optional. I'm going to choose to do it in this case is 125. So we're going to add 125 to this value, which gives us 805. It's going to be 930. And then we're going to have 1,055. Because we're increasing by 125 every time we go over to the right. Going to the left, we're decreasing by 125. So 680 minus 125 is going to be 545. Excuse me, my apologies. No, I had it right the first time, 555. Then that's going to be 430, and then we're going to have 305. Now, once again, we want to find a percentage of light bulbs that are shorter than 720 hours. So 720 will fall between 680 and 805, closer to 680. We're going to call that X. X equals to 720. Because we want to find shorter than that, we're going to shade to the left. If we said more than that, we will shade to the right. It is between two scores, that's in between shading. Now, before you go to your table, you must standardize this raw data. To standardize this raw data, we're going to introduce the z-score formula, such that z is equal to your data value minus your mean divided by your standard deviation. When you go to Stats 250, you'll be using different symbols for Chapter 6. Well, Chapter 11, we call that Chapter 6 in Stats 250. Let me excuse myself. Z will equal to your data value minus your population mean divided by your population standard deviation. But we're going to use this one. No difference, to be honest. Z equals to 720, which is the value that I am comparing the mean to, minus 680. divided by 125. Open up a calculator. So 720 minus 680 equals 40. And then 40 divided by 125 equals to 0.32. If you need to, round your z-score to 2 numbers after the decimal. Now, what we're going to do is we're going to go to our table. We're going to find the probability that z is equal to 0.32. So positive z-scores, go to the positive side. 0.3 is the first 2 numbers. Use the top to scroll over to the 2. That's going to be 0.6255. 0.6255, which means the probability that has a lifespan shorter than 720 hours is going to be 0.6255. And if I write that as a percentage, which I need to, move my decimal over 2 units to the right, that's going to be 62.55%. Remember, if this was shaded to the right, you must take this probability that you have, 0.6255, and subtract it from 1. Then you would turn that into a percentage. Shade it to the left? Don't need to. Alright guys, that's it for this video.